Hey guys, welcome back to AlgoYogi. We are now doing array and hashing series, and our next problem in the list is destination city. So let's go to LeetCode, give this problem a read. You are given the array paths where paths I basically has a pair, which is city A and city B, means there exists a direct path going from city A to city B. Now we need to return the destination city. What is the destination city? It's the city without any path going to another city. So it might have path incoming, but it doesn't have a path outgoing to any other city. So that's the destination city. It is guaranteed that the path, this graph of paths, forms a line without any loop. So there will be no loop. You won't get stuck in any loop. You will be able to visit all the city if you start from somewhere and then get to the destination city, because paths will lead up to that city, and that city does not have any outgoing path, so that's the destination city. So now we need to just return the destination city. So let's go over it, how we're gonna do it. We are given paths, right? We are given paths is nothing but like a 2D array which contains these pair of values, where here it's city A I, and then this is city B I, right? So when we have this pair, it's saying that there is a path from London to New York. There's a path from London to New York, so we can even represent it like this as a graph problem. Okay, yeah, it's becoming like a graph problem. Honestly, like I know it's mentioned in array and hashing, but the way we will be solving this problem is using the hashing. We'll be creating a city map, and then we'll find out which one is the destination city. So here, let's create this graph, and then let's go to the second pair, which is New York to Lima. So there is a path from New York to Lima. Then there is a path from Lima to Sao Paulo. So here, Sao Paulo. All right. So this is our graph. Now you can tell that all of these cities except Sao Paulo have an outgoing edge. I'm only talking about outgoing edge. So there is an outgoing edge from London, there is an outgoing edge from New York, there is an outgoing edge from Lima, but there is no outgoing edge from Sao Paulo. That is why this right here is my destination city. All right, so that is what we have to find, and it's going to be really simple. How? Well, I'm sure like if you have done the graph problems, we have already done the graph series, so you will remember that we can create our graph using adjacency list. And here we will create the graph, and after using like a dictionary or like hashing, basically we're creating this city graph or city map, which is basically a hash map where there is a key is the node or the city, and next to it all the paths that this city leads to. So if there is an outgoing edge for London to New York, then we will have New York as a value next to London. And in the end, given all these cities mapped inside our hash map, if there is a city that does not have a value, that is our destination city. That is our destination city. So let me just get rid of this and move this thing right here, and we're gonna create the graph. Okay, so what I'll do is I'm gonna start visiting all these cities in my path by pair, and I will create city map. So city map basically is a dictionary. Now I start visiting, so I see London and New York, so I'm seeing two cities. So what I'll do is I'll put London, and then I'll put New York as a value next to London. So London has a value, New York. There is an outgoing edge to New York from London. But then I also want to have New York just as key with the empty value, this empty array, which says there is no outgoing edge yet, because I have only seen just one pair of values, right? So but I do want to attach this, because let's say if if this didn't exist, these two didn't exist, then New York would be my answer. So in order to find that New York is the destination city, I will again have to go through this city map and see which city does not have any value inside its array, which is the neighbors, you can say. All right, so but we have two more pairs. Then we go to New York and Lima. So there is a path from New York to Lima, so I will add Lima here, but then also again I will add Lima as key. Okay, then I go to the third value, so this is done. Lima to Sao Paulo, so I will add Sao Paulo to Lima, and then I will also add Sao Paulo, and then with the empty array as like this neighbors list. So what I will do now is I will go through this city and find which key has no value inside its array. All right, so which city contains the empty neighbors list. All right, so this will be all of it. This will be the solution. Now time complexity for this solution would be big of n, because where n is the length of all the paths, and space complexity will also be n, where n is again, because we are storing all these unique city into our, or you can say 2n, because for each pair I am basically when I'm creating the city map, the keys, I use both the keys, both city as keys. Okay, so this could be 2n, but again it's only n because we ignore the constants. 2 is a constant. So let's write our solution. I'm going to change the view right here. So this is what we do. We'll create the city map, and now you see how this appears to be a graph problem, which I'm not gonna lie, it is, but we can solve it just using hashing. We are not doing like any traversal or anything, just like any graph traversal, BFS, DFS. We're not doing anything. We're just creating the map. Using hashing, and then we'll find out which key does not have any neighboring city as outgoing edge. So I will start visiting city, I'm gonna call it city A and city B in my paths. in paths. So now I have both my cities with me. So here is what I'm gonna do. If city A in city map, so if this already exists in city map, then what I do is I will just simply append to my city maps at city A, I will just append this city B as like neighbor. There is an outgoing edge from A to city B, so that is why I will append this city B. All right, so that's first case. And now I will do another thing, is I will check if city B is in my basically in my city map, and if it is, well, first thing is like if this city map if this city A is not in my city map B, then I will do basically the else case, where I will create this I will create this city map A. I will do the same thing. It's just rather than appending, I will just have it with equal. Okay, so this city as value. Okay, so this is it. So now I'm putting this value here. But now if you remember, if you remember that here it might happen that this city B, if this city B might not be in my city map, but I do want to append it. Okay, I do want to create that into like as an empty list. So what I'll do is, if I think I can, it will have to be done in both scenarios. So here I'll do if this city B not in my city map, so what I'll do is I'll append this. So city map city B, and I will just have an empty array assigned to it, empty list. Now what I'll do is, and you can put this inside, like, both of these, but it doesn't matter, right? So, and you can even run it like right in the beginning as well. But just know, like, what we are actually doing with this. We are also checking, we are also putting city B's, as the key. I want to have a city B as key as well. Now it's all about visiting, the keys and values. So key and val in my let me call it key city, and let's call it neighbor list inside in the city map dot items, if length of this neighbor, and I think it's not a good idea to have capital letter there, so length is equals to 0, that means that's the city, that's the destination city. So I will return this, otherwise I will just return none. Sorry, not this, the key city I'm returning the key city, because that's empty, the value is empty. So I will return none in the end, although like they said, I think it's guaranteed that the graph of path forms a line, so there will be a city. And they've also given us, not here, right here, if we go to the destination, to the constraints, there is at least one city, path length is 2, city A, B. Alright, so yeah, we will have an answer. So there is nothing like, there are no cities present. So let's run it. Let's run, and let's see if passes our test cases. City B not in city map. Yeah, of course we meant city map. City map, yes. I think now it's good. Yes. All right. So let's submit. That's our entire code. So time complexity for this would be big of n, because we are visiting just all the pairs of paths. So you can call it P. So number of these paths inside my path array, path list. For space, it's also going to be same. So big of P. Awesome. So that's it. Let's go back to AlgoYogi, mark this problem solved. See you guys later in the next problem. Until then, bye bye.